Okay, so we are going to be talking about preparing salts or creating a salt. But first, let me ask you a question. What is a salt? You probably think about salt. You think about the stuff you put on your food. And that is a salt. It is sodium chloride, but there are many other kinds of salts. For example, calcium sulfate is a salt that is used to make blackboard chalk. In sport, you can use magnesium carbonate to keep your hands dry so they don't slip. Aluminum sulfate is added to dyes to help them stick to fibers. Ammonium nitrate is used as a fertilizer to help crops grow well. Copper sulfate can be turned into a powder and put on seeds to help stop fungus from growing. And then there's sodium chloride, which is used to preserve food and is table salt for flavoring. So salt is a compound that is made when a metal replaces the hydrogen in an acid. Every day, the chemical industry makes hundreds of thousands of tons of different salts. Many methods for making salts start with acids. All acids contain hydrogen. The table below gives the formula of 3 common acids that you would find in the laboratory. The table also shows some examples of the salts that can be formed from these acids. When you look at this chart, what is similar about the formula for hydrochloric acid and the formula for sodium chloride? What do you notice? Hopefully, you notice that the hydrogen has been replaced by the sodium. The same thing happens in sulfuric acid. Here's the hydrogen, and it's replaced by the copper. And down here with nitric acid, our hydrogen is being replaced by the potassium. Also notice that hydrochloric acid makes chlorides. Sulfuric acid makes sulfates. Nitric acid makes nitrates. So it's pretty easy to tell what acid was used based on the name of the salt. Now, we can prepare a salt using metal and an acid, okay? When we're using a metal and an acid, you're going to end up with salt and a hydrogen. It's the most basic, simple reaction when you're creating a salt. For example, let's say that you wanted to make magnesium chloride. You would need 2 reactants. One is hydrochloric acid, and the other reactant must include magnesium. You could use magnesium metal, magnesium oxide, or magnesium carbonate. But in this case, let's just say we're going to use magnesium metal. There is a pattern in the reactions of metals with acids. When a metal reacts with an acid, there are 2 products, salt and hydrogen. So when the magnesium reacts with the hydrochloric acid, the products are magnesium chloride and hydrogen. The word equation for this is magnesium plus hydrochloric acid yields magnesium chloride and hydrogen. You would have to measure out a very specific amount of dilute hydrochloric acid using a graduated cylinder. So you would pour that into a beaker, and then you would add small pieces of a magnesium ribbon to the acid in the beaker. The magnesium is going to react with the acid, and bubbles of hydrogen gas are going to form. After a few seconds, the bubbles would stop. All the magnesium has reacted with the acid. You would keep adding pieces of magnesium to this acid until there would be no more bubbles and a piece of magnesium remains. It did not react. So to get the salt out of the beaker, out of this mixture, you would have to filter it first. So this is going to remove any leftover solid magnesium. Then you're going to pour the magnesium chloride solution into an evaporating dish and heat it until the water starts to evaporate. When about half the water evaporates, you're going to stop heating it and just place it someplace warm. In a few days, the rest of that water will have evaporated, and you'll see the magnesium chloride, and it'll look something like that, okay? You could also do the exact same activity or with zinc. So the next one we have are metal carbonates with acids. When you put carbonate, such as calcium carbonate, which is also known as limestone, is actually a type of salt, and it can be formed by the reaction of a metal with a carbonic acid. We use carbonates to form other salts by reacting them with an acid. So for example, sulfur acid with calcium carbonate gives you calcium sulfate and water and carbon dioxide. Hydrochloric acid, calcium carbonate, yields calcium chloride, water, and carbon dioxide. Nitric acid plus calcium carbonate will give us calcium nitrate plus water plus carbon dioxide. So where did the hydrogen go? That was in the acid, because we didn't say hydrogen specifically, or did we? You're right, we did, because water is H2O. It's got hydrogen in it. So that acid goes out with some oxygen. Now remember, our carbon dioxide is a gas. So again, we're going to see bubbles. Limestone is real good for this. You can put just a little bit of vinegar, which is an acid, on limestone, and it will actually start to bubble. So for our next preparation of a salt, we have to talk about alkalis. Now, we need to know what an alkali is. And you'll remember from your previous lessons about bases and acids, okay? And right in the middle of that are our neutrals. That's water. So it's a 7. And so we have this 0 through 14 scale. And anything that's above a 7 is considered a base. An alkali is a very special base because it can be dissolved in water. That means it's soluble, okay? So it's still going to neutralize an acid, but it's because it's dissolved in water. Now to remember, a low pH means it has a high concentration of hydrogen, and a high pH means it has a low concentration of hydrogen. So when you look at this chart right here, here's our low pH, and we have 0.1 million hydrogen ions. But if you look way down here at these high pHs, look at how tiny of an amount that is when you've got that many zeros behind the decimal point. So high pH, low concentration of hydrogen ions. Low pH, high concentration of hydrogen ions. So what that looks like is it's going to look like this. So an acid plus an alkali. Remember, alkali is a special kind of base. It's going to give us salt and a water. Remember, water is neutral. So you could take your sodium hydroxide and put it with hydrochloric acid, and that's going to give you sodium chloride and water, okay? Now, there's a couple other special things you need to know. Alkalis and bases. So alkali is a base that can be dissolved in water, and then you have your other bases. So for example, when a metal oxide dissolves in water, it forms an alkaline solution. Metal oxides are called bases. Soluble metal bases form alkalis when dissolved in water. So for example, sodium oxide plus water will give you sodium hydroxide. Sodium oxide is a base. The sodium hydroxide is an alkali, and hydroxide means adding water. Again, if you dissolve in water, you become an alkali. Some metal oxides are not soluble in water. For example, iron oxide and copper oxide. So they don't form alkalis, but they can still react with acids to form salts. For example, copper oxide and sulfuric acid is going to give you a copper sulfate and water. So to wrap it up, we talked about a lot of things. Many of these are in your essential questions. Come back, relook at this. A lot of the information in this presentation came from the Cambridge textbooks, the Cambridge Science Coursebook 9, the Complete Chemistry Cambridge, and the Checkpoint Science 3. So if you need to review this information, those books are great resources, or you can come see me.